Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Planet X or Comet Reenergizing Process. Now, Planet X system stellar cores have been coming into the solar system for thousands of years as comets and have therefore been affecting the Earth and the Sun for a very long time. These objects go through a process inside the solar system which allows them to absorb energy and matter from living celestial objects in the solar system. In other words, from objects that have plenty of gravitational photon energy in their particles, and thus a living core capable of both generating a strong gravitational field as well as create matter. Whilst the Planet X stellar cores are severely depleted in gravitational energy and are thus not able to create matter. And you may look at Article 522 entitled Stellar Cores or Sources of Matter or White Holes. This energy-absorbing process allows them to turn into solar system objects. The larger ones that go to the Sun to absorb energy turn into gas giant planets, and the smaller ones which have gone to the Earth to absorb energy turn into Earth moons. And you may look at Article 523 entitled Planet X and the Solar System, Jupiter and all gas giants are recent acquisitions. And Article 526 entitled Planet X and the moon has not always been in the sky. And here you see some of these objects. These two have gone to the Sun, so these are the larger ones that have a bit more gravitational energy. Well, it's still very little for their size, because they are much larger. As you can see, they make these connections with the Sun, and they absorb energy from the Sun. And here you see one in the Earth's atmosphere covered in cloud. These objects are actually the source of clouds. And you may look at Article 410 entitled Planet X inside the Earth's atmosphere. And so these ones will turn into gas giant planets eventually. And these ones will eventually turn into moons. The smaller ones will most likely take a very long time to absorb energy because they can only absorb energy through that cloud. Now, living stellar cores generate a high positive electric field, and the Planet X system stellar cores retain this strong electric field. It is this electric field which stops them from colliding with the surface of any other celestial object. And you may look at Article 514 entitled Stellar Cores or Gravitational Poles or superprotons. Thus, the cores of celestial objects are like protons within the nucleus, and living celestial objects are like atoms, in other words, superatoms, as they have an outer negative layer. Planet X system stellar cores come into the solar system without an outer negative layer, and they do not have the gravitational energy to produce one. But once they absorb gravitational energy, they will be able to eventually produce a negative outer layer and will thus become whole objects or superatoms. However, their cores will remain dead. They will not have the energy to create matter, which is why there are no volcanoes on the moon. It has a dead core. Now, the cores of celestial objects create matter, and therefore all the outer layers of a celestial object is created by the core at the center of that celestial object. Matter emerges in the form of hot positive ion plasma or magma, and as more is created, the older material becomes the outer layers of the object, which eventually cools and solidifies into a rocky surface if it is a planet. In other words, it's small, and becomes the outer, it becomes the chromosphere if the object is larger, and therefore becomes a star. And you may look at Article 524 entitled Mercury created by the Sun due to Planet X. So here we see what a planet looks like. It will have a core. It will have a liquid layer, that's the positive ion plasma or magma layer, which is the form of matter that the core creates. And then it will have an outer layer, which has cooled down, and it's basically weakly solidified magma. And then there's the atmosphere, which is negatively charged. The interior is positively charged, the surface is neutral. And a star is similar, except there's no outer solid layers. This positive ion plasma goes all the way to the surface. So a star is basically a liquid, except for the core, which is solid. And then it has an atmosphere like a planet, which is also negatively charged. But that atmosphere has such a high negative electric field, which is also produced by the core and the gravitational energy in the core, that this atmosphere will go into arc mode, plasma arc mode, and will thus emit light. And you may look at Article 506 entitled Planet X, Earth CMEs, and Star Internal Structure for more details on that. Lighter elements within the magma float upwards towards the surface and end up separating from it, so that water ends up on the surface and gaseous elements end up as atmosphere. At the same time, the gravitational interaction repels electrons outwards to the outer layers, thus creating a negatively charged outer layer. In other words, the atmosphere will be negatively charged. Since it is the gravitational interaction, the charge separation part of it, which causes protons and electrons to repel, and that leads to the formation of this outer negative layer. And since Planet X system stellar cores are low in gravitational potential, they are not able to generate an outer negative layer, and thus operate as positive super ions instead of neutral super atoms like living celestial objects do. And here you can see how you get different density layers, and gravity causes electrons that are a part of the neutral matter that is created. But the moment it's created, the gravitational energy in the core will cause some of those electrons to be repelled and pushed outwards towards the surface. And so this, the atmosphere ends up negatively charged. And the gravitational interaction, the electrostatic interaction, are illustrated here. In the electrostatic, positive and negative particles always attract. So the proton and the electron attracts each other, whilst two positive particles will always repel. Whilst in the gravitational interaction, it's the other way around. A proton and an electron repel. This is the charge separation part of the gravitational interaction, whilst two protons will attract. And that's what gives rise to the strong nuclear force and gravity. It is the strong attraction between two protons, two positively charged particles. And you may look at Book 3 entitled Planet X, Reveal Gravity and Light for more details on this. But one other thing is that the electrostatic interaction does not depend on the gravitational energy or photons within particles, but the gravitational interaction does. So in all these cases, the interaction always has the same strength, whilst here the interaction varies in strength depending on the photon energy inside the particles. So in a star that has a lot of gravitational energy, this repelling force is extremely strong. So you end up with a lot of electrons going to the outer layers, producing a very strong negative electric field on the outside, which then allows the atmosphere to go into plasma arc mode and emit light. And so the gravitational energy always increases towards the center of an object. And gravitational potential is gravitational energy per unit mass. And it increases with distance towards the center. As distance decreases, as you move towards the center of the object, gravitational energy and therefore gravitational potential increases because the object is also denser towards the center. So the core is the denser part of the object. The atmosphere is the least dense part of the object. And so what we have is matter that is made out of very heavy nuclei, lots and lots of protons, which makes this matter very dense. Whilst matter on the outside is gaseous, it's made out of gaseous molecules that have very low density and therefore have low gravitational energy. Very few protons per unit volume or per unit mass. And you may look at Article 5.1.4 entitled Stellar Cores or Gravitational Poles or Superprotons. Since their gravitational energy is so low, Planet X system stellar cores are only capable of extremely weak gravitational interactions. So it is the electric or electrostatic interaction that brings them to solar system objects. They are attracted to their negative outer layers. And since the sun has a huge atmosphere, the heliosphere, which encompasses the whole solar system out to 122 AU, they would have been attracted to the sun's outermost layer and would absorb as much energy as they could from that layer. But even though the electrons in the outermost layer would be very high in gravitational energy, the electron cloud at that distance would be very dispersed, because that layer will have the lowest density, resulting in very low energy per unit mass and also per unit volume. And this is illustrated here. The sun's at the center. This is the heliosphere, and the sun has such a lot of gravitational energy that it manages to push the electrons that have the highest gravitational energy all the way out to the outer rim of the solar system, which is 122 AU away from the sun. And this is basically a sphere all the way around the sun. Now, of course, the sun has changed now, and it's no longer producing the kind of solar wind that it once did because of the Planet X system. But basically, these electrons go out as part of the solar wind, which is created by the sun's core. All the matter that comes, that is part of the sun, that is part of the solar system, is actually came from the sun's core, including the planets that were originally part of the solar system, like Mercury seems to be a new creation of the sun. Now, thus, the objects would move inwards towards the sun, where the gravitational energy per unit volume increases to very high levels. However, there is an effect called gravitational tuning, which does not allow the objects to absorb material with higher gravitational potential than the core. So only the largest Planet X objects would go to the sun, and they would find material of compatible gravitational potential there. Some will only be able to absorb material from the inner corona or atmosphere of the sun, others from different depths of the chromosphere. So most likely the ones that had been stars as living celestial objects go to the sun, and the smaller ones, which had been planets, would go to the planets like Earth. And you may look at Article 5.18 entitled Planet X and Gravitational Tuning for more details. So this is illustrated here. Our stellar core doesn't have a negative outer layer, so it's basically a positively charged. It's like a super ion. And the positively charged particles, this is a superparticle because it will be an astronomical object, will be attracted to the negative layer around solar system objects like the sun. But once they enter the sun's atmosphere or corona, then the shielding effect of the electrons, because the electric field causes a shielding effect, so that on the outside the positive core is not detected. All that the core sees as a result of the electrostatic interaction is the negatively charged outer layer. So the sun will look like a negatively charged particle to it. It's attracted to it. It's only when it's inside that the positive electric field becomes detectable, and now there is a strong repulsion that occurs as a result of that core. And so the object is no longer able to collide, it's no longer able to move any further towards the sun, so it hovers in the atmosphere. The gravitational attraction will be there, although it's very weak. They do seem to still have some ability to interact gravitationally, even though it's a very, very weak interaction. And of course, the electric attraction that ported to the outer layers of the sun will be there as well. There will be a balancing of the forces so that the object is able to remain hovering in the sun's atmosphere for a while. Now, within the atmosphere, the object will absorb the densest material, which will have the highest gravitational potential available, but which is still at a lower gravitational potential than its core. Some objects are only able to draw electrons in through their water cloud formations. Some are eventually able to draw water from the Earth's surface, which is high in gravitational potential, and the largest are able, through their large electric field, to induce the Earth to have matter creation events, which gives rise to volcanic eruptions, or in the case of the sun, to CME events. The magma issuing from the eruption will then attach to the object, and the gravitational energy is absorbed by the core, and this is illustrated here. So a volcanic eruption like a CME on the sun is induced by a large stellar core, which has a high electric field and a higher gravitational potential than the lowest energy magma inside the Earth. And you may look at Article 505 entitled Planet X Creating Earthquakes by Inducing Positive Plasma Current Flows. Magma issuing from the volcano will attach to the object, and the magma's gravitational energy will then flow into the Planet X system stellar core, thus increasing its gravitational potential, so that next time it will be able to attract more magma, and magma from deeper within the Earth. And this illustrates what occurs, and what occurs is actually a magma is created by the Earth's core as a result of this object's electric field, which is strong, overlapping the Earth's electric field, and this causes the electric field on this side of Earth's core to increase to such a point that a matter creation event occurs, and that causes magma to explode outwards from the surface of the core, and that causes magma closer to the surface to move outwards and find a way through a volcano to the surface. And at the same time, this matter that was closer to the surface and strongly positively charged moves towards the surface of the Earth, and then that causes a strong repulsion, so that the object is strongly repelled and ejected. And the same thing happens on the sun whenever there is a CME event. The CME event is basically the same thing: matter creation and eruption, except it does not need to find a way to the surface through a volcano, because the sun, well, at least it did before. Now the sun is producing a solid layer, and I believe, and it's therefore turning into a huge planet. Now, the largest stellar cores will thus often be ejected from the Earth's or Sun's atmosphere at the time of a volcanic eruption or CME. So in the case of the sun, but it will keep coming back for more material until they have gained enough gravitational potential to create their own outer negative layer. In other words, until they have have gained enough gravitational potential to repel their own electrons outwards to the outside of their bodies. When this happens, their outer negative layer will be repelled by the Earth's outer negative layer, and the object will not be able to enter the Earth's atmosphere, or in the case of the sun's inner corona anymore, and will thus go into orbit around its host at the appropriate orbital distance for its overall gravitational potential. So once this object is able to create its own negative outer layer, it will be repelled by the Earth's negative outer layer. It will not be able to enter in anymore. And it will then find some distance where the gravitational and the electric repulsion are in balance or nearly in balance. You need a weak force that is attractive for the object to remain in orbit. And then the object will go into orbit around the Earth, and this is how a new moon for the Earth will form. And the gravity, the force that we call gravity, is actually the sum of the gravitational, which here is represented by a green arrow, which is also the same as the strong nuclear force, and the electric force. So these two forces, when added together, gives rise to a small attractive force, which is what we usually refer to as gravity, as the force that causes objects to orbit other objects. And you may look at Article 514 entitled Stellar Cores or Gravitational Poles or Superprotons for more details. And then what happens is they will go into orbit. So if they had been to the sun, because the gravitational potential increases as we move towards the sun, the object will basically find an orbital position that is consistent with its own gravitational potential. So the objects with lower gravitational potential will go into orbit further out from the sun. And this is why Jupiter, which is basically a Planet X object that has gone through the process of re-energizing or being re-energized by going to the sun and absorbing matter from it, is out there because it has a dead core with very little gravitational photon energy in it. So it has low gravitational potential for its size. You may look at Article 523 entitled Planet X and the Solar System, Jupiter and all gas giants or recent acquisitions. The Planet X stellar core will then behave like a normal solar system object and obey normal gravitational laws, but it will seem to be of very low density as it still has a dead core, which, although of higher gravitational potential than before, it is still low in comparison with living celestial objects. Thus, even though the object, and particularly the core, will be large and dense, it will seem to be of very low density and mass due to its low gravitational energy status. This is why planets such as Saturn are thought to be made entirely of gas, and why the moon is believed to have a very small core and be of a much lesser density than Earth. They are re-energized Planet X system objects and thus have dead cores. They are also extremely destructive before and during the re-energizing process, and thus extremely dangerous to life on Earth. So in conclusion, Planet X system stellar cores develop into solar system objects through a process that can be understood in terms of the theory of gravity I have developed based on the observation of these objects in the sun's corona. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.